Hello. In this slideshow, we will see some examples from mechanics. Actually, it is a dynamics and from the chapter central orbits. In this example, we will see a particle describe the following curves under force F. Then we have to find that force. Okay, the first example is suppose r raised to n into cos of n theta is equal to some constant a raised to n. The first step is put r is equal to 1 by u. Then this equation reduces to cos of n theta into 1 upon u raised to n. Transfer this u raised to n in the denominator towards the right side. So it will become a raised to n u raised to n. Now we have to find its first derivative. So we will use the logarithmic differentiation. Take log on both sides. Log of cos of n theta is equal to log of a u raised to n. Using the logarithmic simplification, this can be written as n log of au. Now differentiate this expression with respect to theta. So we'll get derivative of log is 1 upon cos of n theta. Then derivative of cos is minus sine n theta. And the derivative of n theta is n equal to the derivative of the right side is n into 1 upon au into a du by d theta. So a get cancelled, this n get cancelled, and we got minus tan theta, tan of n theta is equal to 1 upon u du by d theta. Is it? Now again simplify this as a du by d theta is equal to minus u into tan of n theta. So this is our first derivative of u with respect to theta. Now we will find its one more derivative with respect to theta. So differentiate with respect to theta, we'll get d2u by d theta square is equal to, this is the first function, this is the second function. We can use rule of product of derivative. First function as it is, derivative of tan is sec square n theta, derivative of n theta is n, plus derivative of first function, that is minus du by d theta, and second function as it is, that is tan of n theta. Okay. Now if you see here, the cos n theta is a raised to n u raised to n, and therefore we can find the reciprocal of this equation. We'll get sec of n theta is equal to 1 upon a raised to n u raised to n, and if you take its square and use this sec square n theta value here, okay, here, and you know that du by d theta is minus u tan n theta, we can put this value here. So the next equation is d2u by d theta square, this is the left side, is equal to, see the first term, that is minus un minus u into n into 1 upon a raised to 2n into u raised to 2n. Okay, this is the value of sec square n theta. Then I'll put the value of du by d theta here. So minus minus plus, then it will become u tan square n theta. So it is plus u tan square n theta, and tan square can be written as, you know that this can be written as 1 plus sec square n theta minus 1. So we can write this as minus un upon a raised to 2n u raised to 2n plus u. The value of sec square n theta is 1 upon a raised to 2n u raised to 2n, and this is minus 1. Okay, so after simplification you can write this as a after some simplification you may write this as a 1 minus n upon a raised to 2n, and it can be written as 1 upon u raised to 2n minus 1. Okay, so this is no, here we will write d2u by d theta square plus u. We are adding plus u on both sides, and then after simplification we will get this one. Why we are finding this left side d2u by d theta square plus u? Because we know that the equation d2u by d theta square, this is, we know that plus u is equal to f of u upon h square into u square, where h is any constant. So the left hand side is ready to use, and therefore from these two equations we can write f of u divided by h square u square is equal to 1 minus n divided by a raised to 2n, and this can be written as 1 upon u raised to 2n minus 1. And therefore if you transfer this denominator to right side, you will get f of u is equal to 1 minus n upon a raised to 2n, and you will get something what you are getting. This is u raised to minus 2n plus 1, and this is plus 2 and into h square, and therefore this is a constant, h square is a constant. We keep this both constant denoted by mu. Then we will get the answer is u raised to f of u is equal to mu, and this is u raised to minus 2n plus 3, u raised to minus 2n plus 3. This can be written as mu into 1 upon u raised to 2n minus 3, and we know that 1 upon is equal to r, therefore it can be written as mu r raised to 2n minus 3. And this is the required force that is directly proportional to r raised to 2n minus 3. So we finish this example by getting this. Keep remembering this example. Firstly find du by d theta, then find d2u by d theta square, then add u both sides and simplify this and get the expression in terms of u, and some constants we can denote it by mu. So let us see another example for the finding force. That is, r is equal to a into sine of n theta. All right, put r is equal to 1 by u, so we'll get 1 is equal to a into u sine of n theta. All right, so we can rewrite this expression as au is equal to transfer this sine to this side. 1 upon sine n theta is nothing but cosec n theta. Now take a log on both sides. Log of au is equal to log of cosec n theta. Now differentiate with respect to theta. So derivative of log is 1 upon AU into derivative of AU is A du by d theta is equal to derivative of log is 1 upon cosec n theta into derivative of cosec is minus cosec n theta into cot n theta. Derivative of n theta is n. Alright. So cosec n theta get cancelled. AA get cancelled, and you are getting du by d theta is equal to minus n u cot of n theta, if I am correct. Okay. Now differentiate again with respect to theta. You will get d2u by d theta square is equal to suppose this is the first function, keeping first function as it is, derivative of second, that is minus cosec square n theta into n plus cot of n theta keeping as it is, and derivative of first function, that is minus n. So after simplification, this minus minus get plus, so we'll get n square into u cosec square n theta, and we know that cosec n theta is AU, so its square is A square U square, right? Minus this is something, okay, minus n, and this is remaining du by d theta. Now we put du by d theta here, so you will get minus minus plus n square u, and again you are getting cot square n theta. Now I hope that we can take common n square u, n square u, I think, from this. Okay, and cot square n theta is we can write cosec square n theta minus 1. So the next step will be d2u by d theta square is equal to, see, the first term is n square a square u cube, n square a square u cube, a square u cube, plus the second term is n square u, n square into u cot square theta, and cot square theta can be written as cosec square n theta minus 1. And we know that cosec square n theta is nothing but a square u square. So we can write this as n square a square u cube plus n square into u. This is a square u square minus 1. Okay. After simplification, we can write this as n square a square u cube plus n square a square u cube. This is minus n square u. Now adding u both sides, I will get d2u by d theta square plus u is equal to this is 2 times n square a square u cube, and plus 1 minus n square, and u taking as a common. Okay, so we know that this term is equivalent to f of u upon h square u square. It is equal to 2n square a square u cube plus 1 minus n square u, and therefore finally f of u I'll get 2n square a square h square u raised to 5, and here 1 minus n square into h square u cube. All right, so this is the answer, and we know that u is 1 upon r, and therefore the final answer of this force is 2n square a square h square upon r raised to 5 plus 1 minus n square h square upon r raised to 3. So this is the required answer. Thank you.